Hi, Assalamualaikum. My name is Muhammad MUADDIB BAKHTIAR bin MUZAFAR. My matric number is B081910327. Today, I want to explain about lab in digital electronic. The topic is counter. So we go to the circuit that given, this one, figure 1.1 and figure 1.2. Okay, for part 1, as we can see here in the procedure, it asks to construct a 3-bit count up ripple counter shown in figure 1.1. This circuit. So okay, and then the counter will have Q0, Q1 and Q2 as the output. Connect each output to probe indicator and 7-segment display. And then observe the probe indicator and 7-segment display and record it in table 1. Okay, this is the part 1 for the table. This is the circuit. I screenshot every single one that shows different number and different reaction at the probe. So we go to the multi-sim. I will show a demonstration. Okay. This is part 2. Okay, this is part 1. Okay, part 1. The difference for part 1 and part 2 is, from what I see, is part 1 we have to do it manually, and then part 2 we just have to adjust the frequency to make it go slower as we want to read the LED, the probe and the 7-segment. So we run the circuit and then we push the button. As you can see here, for 7 it shows 111. If the probe light up, it means 1, and if the probe didn't light up, it means 0. So okay, then 6 0 1 1 5 1 0 1. We have to, as I record it as from the x3, x2, x1. Okay, and then that is for part 1. Okay, and then part 2. Part 2 we have to use clock voltage that will make the counter go automatically, but we have to adjust the frequency to make it go slower. I will show some demonstration. So this is the result for part 2. This is the table, and this is the screenshot for each number that showed up in the 7-segment display. And then I will show the demonstration for part 2. Okay, part 2, as we can see here, the number change slope, but when I first build this circuit, the speed of transition that from one number to one number is very fast. it was 1K at first, so it will go very fast like this. And then I found out that we have to change the frequency here to make it slower so we can read it better and more accurate. So I changed it to 0.5 Hertz. Okay, have to stop it first. As we can see here, the transition from one number to one number, it is much slower, so it will be more easier to read the probe and the number. So we can say number 2, this is 0, this is 0 if the probe didn't light up, and if the probe light up, it means 1, it indicate 1. This is the demonstration for part 2, and this is the result.